Session 4.3 Modeling Linear Trends. Use technology to write the regression equation. For these sessions, we're gonna learn how to create the regression equation. Remember on the session 4.2, we talk about the scatter point. When we draw the straight line from there, if all the points close to the straight line, we're gonna say that is a strong linear correlation. And what is that straight line? That straight line we call this is the regression equation. So after verifying that the linear correlation between two variables is significant, the next step is to determine the equation of the line that best models the data. The line is called a regression line, and its equation can be used to predict the value of y for a given value of x. So look at this example. Given a collection of pair sample data, the regression line or line of best fit is the straight line that best fits the scatter plot of the data. So we do have an explanatory variable and responsible variable, the x and the y here, and then this is the scatter plot. So we could see for the trend, this is increasing, right? This is a positive linear correlation, and that is a strong linear correlation. So let us draw the straight line here. This is called regression line, okay? Regression line. And remember, you guys learned it from the algebra. We do have the straight line equation, y equal to a plus bx. Let me talk a little bit about the straight line. Okay, remember you guys learned it from the algebra. We do have a straight line. The equation is y equal to mx plus b. Remember that? Okay, so I just switched this guy here. So y equal to b plus mx. Remember what is your m equal to? The m is talking about the slope. And then the b in here, this is talking about the y-intercept. Okay, this is a linear equation. Okay, linear equation. So the slope, we can have a positive slope or negative slope. I just show you guys that one, okay? When your line is going like this way, the slope m will be equal to 0. Okay, if I go up here, the slope will become a positive slope. Just like our scatter plot, if this is increasing the uphill, that will be positive. And then when we go on the vertical, the slope will be equal to undefined. Okay, undefined here. And then when we're going in decreasing the downhill here, the slope that will become negative. Okay, so when you guys look at the regression equation, you always can predict like what is your slope equal to. It's going to be positive or negative. And then the y-intercept. Remember what is the y-intercept, right? Y-intercept is just talking about the straight line pass through the y-axis. This is equivalent to your b here. That's called y-intercept. Okay, you guys should learn it from the algebra. The linear equation y equal to mx plus b. Okay, you know the slope, you know the y-intercept. So now come back to our statistic class in here. For the regression equation, we'll be using another notation. We will have y equal to a plus bx. Okay, the a here same idea. This is talking about the y-intercept. And then the b here, this is equivalent to your slope, equal to your m. Okay, this is the regression equation. Okay, so this is the regression equation, y equal to a plus bx. One more time, a is talking about the y-intercept, the b talking about the slope. So from this example, the slope should be increasing, so b should be positive numbers. And then the x-axis here, or you could think about like the data, the order pairs, the x and y. The x, we call this as the explanatory variable or predictor variable or independent variable. I like to use independent variable here, okay? Y, we call this as response variable or dependent variable, okay? I'm gonna call dependent variable for the y here. Okay, so look at this line here. This line is called a regression line, and its equation can be used to predict the value of y for a given value of x. Why x is called independent variable? Because most of the time they will be given the x, and then we're gonna use the regression equation to find out what is your y here. And that's why y is called the dependent variable. Okay, one more time, A is a y-intercept and the B will be the slope. Okay, look at this example. The scatter plot shows fairly strong positive linear change. It's going to be going increasing here. The regression equation has a slope of 2.16. Okay, there's a slope, so B equal to 2.16. And then the y-intercept, which is going to be your A, of 30.46. Positive trend indicates that players who hit more home runs tend to have more RBIS. Okay, so we're gonna write down the regression equation. They given the A, they given the B, put it back. Okay, this is the regression equation in here. Okay, example 2, using the regression equation. How do we use it when we have the regression equation? So like this example, the scatter plot shows a negative linear trend. As age of car increase, value tends to decrease. The regression equation is, okay, we do have the equation given here, predict value, which is gonna be your y equal to, this is the y-intercept. It's talking about like this point here, minus they use the negative because this is a decreasing, so that's a negative slope. And then the age here, this is talking about the variable of x. Okay, so I will write it to the regression equation. And then use the regression equation to predict the value of car that is 12 years old. So they want you guys use the regression equation here when the value of the car, okay, the value of car is 12 years old. So they're talking about the age, x is equal to 12. What is the predict value of the y in here? Okay, what is the value of the y in here? So we just strictly plug it in. Use your calculator. You're gonna find $6,795 when the car is 12 years old. Okay, this is how we use the regression equation. Later on, you're gonna find we may not use the regression equation. It really depends on the situation. If they do have a strong linear correlation, we do have a higher chance to use the regression equation. But if they have really weak linear correlation, we may not want to use the regression equation to find the predict value. Okay, this is the instruction how to find the regression equation and construct a scatter plot with the regression equation using the calculator. Okay, let's do together. Click on the stat, click on number 1 added. First, I'm gonna delete all the data in the L1 and L2. Now I'm gonna input the height on the L1 and the weight on the L2. Okay. That's the same idea how you guys finding the R, the correlation coefficient from previous session. So once you're done for the input the data, you're gonna click on the stat, go to the text, and then go up, you're gonna find the linear regression t-test. Okay, linear regression t-test. Enter. My data is gonna be on L1 and L2 here. And remember, you're gonna choose not equal to 0. Okay, and then go to the regression equation. I need the regression equation. So I'm gonna press the VARS, go to the Y VARS. And then I'm gonna choose number 1 for function. Okay, you're gonna look at here, there's nothing in here except the Y1, Y2, Y3, okay? Click on the number 1, Y1, and then go to calculate. Enter. So you're gonna see the regression equation y equal to a plus bx. And then they given a equal to negative 442.88. And then the b is 9.029 here. Okay, so 1 to 2 decimal space. So your equation will be y equal to a plus bx, right? So y equal to negative 442.88 plus 9.03x. That will be your regression equation. Okay, now B, compute and interpret the correlation coefficient R. So after you write down the regression equation, you go down, you will find the R here, 0.8809. Okay, 1 to 2 decimal space, so it's only like 0.88. So 0.88, that is really close to 1. Okay, so how can you interpret the correlation coefficient? Think about it. Okay, once you get all this information, I want you guys construct the scatter plot using your calculator. So once you're done, you're gonna click on second, stat plot, turn on the first one. You will choose the first icon. My X list will be L1, Y list is gonna be L2. Okay? And then you're gonna click on zoom. Number 9, zoom stat. So you will see I have the scatter plot with the linear regression equation. Okay, this is gonna be the regression equation. Okay, make sure you guys know how to do it. I may ask you guys construct the scatter plot with the regression equation in the midterm. Okay, go back to here. So first, the regression equation will be equal to this guy. And then y is represent your weight. Okay, this is a dependent variable. And then the x represent the height here. This is an independent variable. Okay, and then r equal to 0.88. Interpret the correlation coefficient. So that is positive and strong correlation. C, use the regression equation to predict the weight of a woman who is 65 inch tall. So they given the x in here. This is to represent the height. Okay, x equal to 65. What is your y equal to? So for the part C here, we're gonna know we will be using the regression equation because the R here, this is a strong and positive correlation. If R is close to 0, we may not want to use the regression equation. Okay? So use your calculator. So y will be equal to 144.07 inch. And then D, we are not done yet. I want you guys construct a scatter plot with a regression equation. So we just use the calculator construct the scatter plot with the regression equation. So you could just copy it from here. Okay. Hey, on the exam, I need you guys label the x-axis, label the y-axis, and also the title of the scatter plot. Okay. Couple things. On the midterm, I need you guys label the x-axis, label the y-axis, the title of the scatter plot. Okay, note about the regression equation. Order matters. If x and y switch, the regression equation will change. Remember when we finding the R, the correlation coefficients, we say x and y switch, you're gonna get the same R. But not the regression equation, okay? When you switch x and y, the regression equation will change. We use the x variable to make predictions about the y variable. So the x variable is called the predictor variable, and it is also called the independent variable. Every time they will given the x and ask you to find the y. And then the y variable is the predicted variable. It is also called the dependent variable. The y will be depending on your x in here. Okay, example 4. I want you guys try to do it by yourself. Find the regression equation. And compute and interpret the coefficient R. Okay, check your work. You should get this regression equation. And then R doesn't change. Right? It's also equal to 0.88. Okay, you should realize example 4 and example 3 exactly the same questions. We just switch the weight and the height. Okay, you're gonna see when we switch the x and y, regression equation will be different. But the R is stayed the same. So again, it's gonna be strong and positive correlation. Okay, interpreting the slope of the regression equation. Slopes tell us how much the y variable change when the x variable is increased by 1 unit. And its slope goes to 0 means there is no linear relationship between x and y. Okay, think about it. When slope equal to 0, that will be horizontal line. So it's not increasing, not decreasing. So another way to say there is no linear relationship between these two variables. Okay, how about the y-intercept? The y-intercept is predicted value when x is equal to 0. When x is equal to 0, y value will be strictly equal to the y-intercept. The y-intercept is meaningful only if it makes sense for x equal to 0. Like some data when x equal to 0, your y-intercept may be equal to negative value, but it's not meaningful for the data. Example 5. Interpreting the slope and the y-intercept. So the given the regression equation is y equal to negative 442.88 plus 9.03x. So you're gonna know y will be the weight and then the x will be your height. So we want to interpret the slope of the regression equation. First, the slope that would be equal to 9.03. And we want to specify what is the y variable represent to and what is your x variable represent to. Okay, so slope of the line is 9.03, y variable is the weight, and the x variable is the height. So now we're gonna interpret the slope. What does this slope means? When you add 1 inch in the height, then the weight will be increased by 9.03. So this is the meaning about the slope in this equation. Okay, so for every additional inch in height, the weight gonna be tends to increase by 9.03 pounds. Okay, so we try to rewrite this sentence. Every increase of 1 inch in height is associated with an increase in the weight of 9.03 pounds. Okay, interpret the y-intercept of the equation if appropriate. So think about it. For the y-intercept, that means when x equal to 0, y will be equal to this value. So when a person is a 0 inch tall, that person, the weight will be negative 442.86 pounds. Is it possible? No, right? Because first, that's no way a person can be the 0 inch tall. And also, that's no person the weight will be the negative pounds. So we could say this y-intercept will be meaningless in this equation. Okay, last example. Figure below shows the relationship between the age and the Kelly Blue Book value for a sample of cars. So they have the regression equation, the predict value, the y, equal to 21,375 minus 1,215 age. The age is talking about the years of the car. And then this is going to be the selling price. So interpret the slope of the regression equation. So first, I want you guys try to do it by yourself, just like the previous example. Tell me what is your slope and what is your x variable means, what is your y variable means. Okay, and then interpret the slope. Okay, the slope is going to be negative 1,215. And then x variable is talking about the age. Y variable is going to be the value of the car. So interpret the slope. When the age of the car is increased 1 year, that means the value of the car is going to be decreasing because this is a negative. And will be decreased about $1,215. Okay, for each additional year of the age, value of the car tends to, okay, we're gonna use this word, tends to, decrease by 1,215. If this is a plus, then will be increasing. Okay, rewrite this sentence. Each additional year of age is associated with a decrease of 1,215 in value. Okay, interpret the y-intercept of the equation if appropriate. When x is equal to 0, that means the age of the car is going to be 0 also. Then the value is going to be 21,375. Does it make sense to you guys? Yes, right? Because when the car is new, okay, they're talking about the number of the age of the car. If the age of the car is 0, that means that it will be the new car. So when the car is new, the value of the car will be selling $21,375. So in this example, the y-intercept is meaningful. Okay, that's it.